Solutions can be adjusted in terms of their concentration. They can be diluted or they can be concentrated. It may seem like it's a difficult thing to do to take a 0.75 molar sodium hydroxide solution and change it so that the concentration becomes 2.17 molar. But in fact, it's pretty easy because of this wonderful formula, which is the concentration and dilution formula. So by the end of this screencast, you should know what the formula is that makes it easy to do that concentration and dilution formula. We'd be giving it to you on a test. And one thing to think about, going a little bit deeper, is why it's not generally a good idea to precisely concentrate a solution by adding solute. It's usually easier to add or remove solvent. Think about that when you're watching this and try to understand why that might be a poor method. This is Screencast 11.9. We'll practice solving these types of problems, and here's one right here. In general, as you add solvent, the concentration is going to decrease. You're going to make things more dilute. Since it's an inverse formula, it has a general appearance like Boyle's law, P1V1 equals P2V2. Inverse laws are easy to predict the formulas for. So, this is a deceivingly powerful formula. It shows up over and over again. It's perhaps one of the most used formulas by a chemist. Okay, so the concentration can be in the terms of molarity or any of the other units. Molality, percent by volume, mole fraction, etc. The volume can be any units you want. Liters, milliliters. Of course, you have to use like units so your units cancel. And let's do an example. You happen to have about 53 milliliters of a 1.5 molar solution of sodium chloride, but you wish it was 0.8 molar. It sounds like we're going to need to add water. How much? Well, just plug in. This is our original volume. This is our original concentration. Here's our new concentration. We can solve for the new volume. Write the formula down. Plug in everything except that new volume, and that new volume must be equal to all that divided by 0.8 when we divide both sides by 0.8 to cancel that out. And we find that it's equal to 100 mils. Common error. You're not done yet. You need to give a sentence for this answer. So, answer. You've got 53.4 milliliters. Should you add 47.6 mils? That would be very, 46.6. That would be very close, but what if these things are perfectly additive? Strangely, 50 mils of sodium chloride and 50 mils of water is not exactly 100 mils, so we word this carefully and we say just dilute it to 100 mils with water. And that should work perfectly. This is Screencast 11.9.